If you're in Seattle, Minneapolis, or anywhere in the northern United States, you need to look up this weekend. The northern lights are coming south. A coronal whole solar wind stream is arriving on March 13th. NOAA's Space Weather Prediction Center is forecasting a G1 geomagnetic storm. KP index reaching 5 by the afternoon of March 13th. And when KP hits 5, the aurora becomes visible from latitudes that almost never see it. Seattle, Minneapolis, Edinburgh, the Scottish Highlands, northern Montana, even parts of Canada and Tasmania could see auroral displays this weekend, March 13th through 14th, and you have time to prepare. Hey everyone, welcome back to Static and Soil. Today we're doing something a little different. Not a volcano, but one of Earth's most spectacular atmospheric phenomena, the Northern Lights, and they're about to put on a show. Let me tell you what's happening, where you need to be, when to look, and how to maximize your chances of seeing one of nature's greatest light shows. First, let me explain what the Northern Lights actually are, because understanding the mechanism makes them even more incredible. The sun is constantly ejecting charged particles, protons and electrons streaming away from its surface at hundreds of kilometers per second. This is called the solar wind. When that solar wind reaches Earth, it interacts with our planet's magnetic field. Earth's magnetosphere acts like a shield, deflecting most of the particles around us. But some particles get funneled toward the poles. They spiral down along magnetic field lines and slam into atoms and molecules in our upper atmosphere, between 100 and 300 kilometers above the surface. When a charged particle from the sun collides with an oxygen or nitrogen atom in our atmosphere, it transfers energy. The atom becomes excited, and when it relaxes back to its normal state, it releases that energy as light. Oxygen gives you green and red auroras. Nitrogen gives you blue and purple. The altitude determines the color you see. And when billions of these collisions happen simultaneously across the sky, you get the Northern Lights. Curtains of green light rippling across the heavens, pillars of purple and red shooting upward, dancing, shimmering, constantly shifting. It's one of the most beautiful things you can witness in nature. Now let me tell you why this weekend is special. The sun has coronal holes. These are areas where the sun's magnetic field opens up, allowing solar wind to escape more easily and at higher speeds. Right now there's a large coronal hole facing Earth, and the fast solar wind from that coronal hole is heading our way. Space weather forecasters at NOAA have been tracking this. They know when the solar wind left the sun. They know how fast it's traveling, and they can predict when it will arrive at Earth. The forecast March 13th. When that high-speed solar wind stream hits Earth's magnetosphere, it will compress it. It will inject energy into our magnetic field, and that energy will be released as geomagnetic activity. NOAA is predicting active conditions with possible isolated periods of G1 minor geomagnetic storming. G1 means minor. It's not a massive storm, but it's enough. The KP index, which measures geomagnetic activity on a scale from 0 to 9, is forecast to reach 5 by the afternoon of March 13th. And when KP hits 5, the aurora oval expands. It moves south. Cities that rarely see the Northern Lights suddenly have a chance. Let me tell you where you might be able to see it. If KP reaches 5, aurora may become visible from Seattle, Washington, Minneapolis, Minnesota, Edinburgh, Scotland, the Scottish Highlands, Hobart, Tasmania. That's not saying you're guaranteed to see it from those cities, but it's saying the aurora could be bright enough and far enough south that if you're north of those latitudes and you have clear skies and low light pollution, you have a shot. In the United States, that means northern tier states: Washington, Montana, North Dakota, Minnesota, Wisconsin, Michigan, Maine, parts of Idaho, Wyoming, and northern New York. In Europe, it means Scotland, northern England, Ireland, Scandinavia, Iceland, northern Germany. In Canada, pretty much anywhere has a good chance, but especially the northern provinces. And the farther north you are, the better your chances. If you're in Fairbanks, Alaska, or Tromsø, Norway, or Reykjavik, Iceland, you're almost guaranteed to see something if the forecast holds. But even if you're in Seattle or Minneapolis, it's worth staying up late and looking north. Now let me tell you when to look, because timing matters. The coronal hole stream is expected to arrive on March 13th. Geomagnetic activity could extend through March 14th. The best viewing times are typically late evening through early morning. Between 10 p.m. and 2 a.m. local time is often the peak. But here's the thing about auroras. They're unpredictable. They have substorms, periods of intense activity followed by quiet spells. You can't just look at the sky at midnight, not see anything, and go inside. You need patience. You need to be willing to wait, to check repeatedly. The aurora might start at 11 p.m. or 1 a.m. or 3 a.m. You don't know until it happens. That's why aurora chasers talk about luck. You can do everything right, be in the perfect location, have clear skies, and still miss it because the peak activity happened while you were inside getting coffee. Or you can stumble outside at just the right moment and witness the most incredible light show of your life. It's unpredictable, and that's part of what makes it magical. Let me give you some practical tips for maximizing your chances. First, get away from light pollution. Cities are terrible for aurora viewing. The glow from streetlights, buildings, and cars washes out the faint green of the aurora. You need darkness. Drive out of the city if you can. Find a rural area, a park, a field, somewhere with minimal artificial light. The darker your location, the fainter the aurora you'll be able to see. And G1 storms often produce faint auroras, so every bit of darkness helps. Second, look north. The aurora appears in the northern sky if you're in the northern hemisphere. You want a clear view of the northern horizon. Mountains, trees, buildings, anything blocking your view to the north will reduce your chances. Find an open area with a wide view. Third, check the weather. Clouds block the aurora. You can have the most intense geomagnetic storm in history, but if you're under thick cloud cover, you won't see anything. Check the cloud forecast for your area on March 13th and 14th. If it's cloudy, you might need to drive to a location with clearer skies. Fourth, let your eyes adjust. It takes 20 to 30 minutes for your eyes to fully adapt to darkness. Don't look at your phone. Don't use flashlights unless they have red filters. Stay in the dark and let your eyes open up. You'll be amazed at how much more you can see after 20 minutes in complete darkness. Fifth, bring a camera. Modern smartphone cameras can capture auroras, especially if you have night mode or long exposure settings. A DSLR or mirrorless camera with manual settings is even better. Set it to a wide aperture, high ISO, and an exposure time of 10 to 30 seconds. Point it north and start shooting. Often the camera sees more than your eyes do. You might think the aurora is faint and underwhelming, but when you look at the photo, it's vibrant and green. Sixth, be patient. I know I already said this, but it's worth repeating. Auroras are not constant. They flicker. They fade. They surge. If you see nothing at 11 p.m., check again at midnight, and again at 1 a.m., and again at 2 a.m. The aurora might wake up at any moment. Now let me talk about why 2026 matters for Northern Lights viewing. We're in the declining phase of solar maximum. Solar cycle 25 peaked in 2024. Activity is still elevated in 2026, but it's starting to decline. Over the next few years, geomagnetic storms will become less frequent. The aurora will retreat farther north. Opportunities like this will become rarer. By 2030, we'll be approaching solar minimum. G1 storms will be uncommon. The aurora will mostly be confined to the Arctic Circle. And we won't see another solar maximum until around 2036 or 2037. So if you're in the northern United States or southern Canada or the UK, and you've never seen the Northern Lights, this weekend could be your chance. Not guaranteed, but possible. And when it comes to auroras, possible is all you get. Let me tell you what to expect if you do see it. A G1 storm produces relatively faint auroras. Don't expect the bright, vivid curtains you see in photos from Norway or Alaska. You'll probably see a green glow on the northern horizon. It might look like distant city lights at first, but then it'll start to move, slowly shifting, brightening and dimming. If you're lucky, you might see vertical rays, pillars of light reaching upward, or a faint arc stretching across the northern sky. The aurora might pulse, flicker, dance. It's alive in a way that photos can't capture. And if you're really lucky, if the substorm intensifies, you might see the aurora spread across the entire sky. Overhead, all around you, swirling in every direction. That's rare for a G1 storm, but it can happen. And if it does, you'll understand why people chase the aurora. Here's what I want you to do this weekend. If you're in the northern United States, Canada, northern Europe, or anywhere else with a shot at seeing the aurora, make plans. Check the cloud forecast, find a dark location, set an alarm for late evening, and go outside. Bring a camera, bring warm clothes, bring patience, and look north. You might see nothing. The forecast might be wrong. The storm might fizzle. The clouds might roll in. Or you might see one of the most beautiful natural phenomena on Earth. the northern lights, the Aurora Borealis, curtains of green and red and purple dancing across the sky. Subscribe to Static and Soil because we're not just covering volcanoes. We're covering all of Earth's most incredible phenomena. This weekend, March 13th and 14th, the northern lights are coming south. Don't miss it. Thanks for watching. Clear skies to you. Static and Soil, where Earth meets sky and the Aurora dances.